For question 60, let's look at the same thing. Again, we're looking for the limit as h approaches 0, p of x plus h minus p of x all over h. And in terms of this function, I'm going to take the limit as h approaches 0, and x plus h will get plugged in for the x. So this will be a little bit cumbersome. We're going to have x plus h plus 5 minus p of x is just square root of x plus 5 all over h. And just like before, we need to somehow release all of these variables from the square roots, so we'll use a conjugate, x plus h plus 5 plus square root of x plus 5 over the very same thing, right? And write it out. Even though it's tempted to put, like, shortcuts, don't do it. You're doing a demonstration here. So when you FOIL out on the top, what we know is that we'll still have limit. We haven't taken care of that yet. But we know that we're going to have a situation where we're multiplying two conjugates together. The middle terms will drop out. We'll just take the square of each of those. So the square of this is just x plus h plus 5 minus the square of this thing, which is going to be the quantity x plus 5 all over h times that other stuff, x plus h plus 5 plus square root of x plus 5. Then when we clean up the numerator, we notice our x's will be dropping out, our 5's will be dropping out, and we're just left with h over the bottom. So this is going to give us just 1 over the square root of x plus h plus 5 plus the square root of x plus 5. And now it is perfectly safe for us to plug in 0 for h. So this will become 0, and we'll just be left with 1 over square root of x plus 5 plus square root of x plus 5, which is just going to give us 1 over 2 times the square root of x plus 5. And that's our derivative. And while I'm here, I'm just going to talk about e. 6e, we're going to take the limit as h approaches 0 of m of x plus h minus m of x all over h. And for this particular function, right, what we know is that m of x is 2 to the x. So that we'll have the limit as h approaches 0 of 2 to the x plus h minus 2 to the x all over h. We can simplify this a little bit. Limit as h approaches 0. I can rewrite this as 2 to the x times 2 to the h minus 2 to the x over h. Again, my goal is to cancel out this h in the denominator. Limit as h approaches 0. I can factor 2 to the x out of each term, but I can't go anywhere with that. So there's no way that I can find h as a factor of the top. So this is as far as we can go right now until you know a little bit more about limits.